Today's lesson will be looking at a few other terms in financial mathematics. These are starting with the present value, which is the amount invested, or the principal, as you know, that will grow to some value in the future, and that's called our future value. So that's what I've explained there, the future value, which is FV. The amount of the investment is worth after a period of time, given number of years. So you start with a present value, which is some amount of money that you put in the bank. You wait a number of years or months, it will gain interest in the bank, and then it will grow to some future value. Now remember what we talked about before with compound interest formulas. We've got A is equal to P bracket 1 plus R to the power of N. Now this is now rewritten so that A is now FV and P is now PV, which is our future value and our present value. Now, our interest factor here is basically all of this. Okay? So it's 1 plus R all to the power of N. And we're going to now look at that in tables. So, compound interest tables simplify calculations. The values in the table are called future value interest factors, as they give the future values of an investment of $1 at a certain interest rate and time. So if we have a look at all these numbers here in the table, they each actually just represent this part of the formula. So it's the part where it goes 1 plus R to the power of N, and that's what we call our interest factor. So it's basically what $1 of our present value will grow to, okay, given a number of periods and given a percentage. So if I was to just, try to have a look at this one and how this is generated, well, this actually brings us to number 26%, and horizontally it grows to number 7 as our period. So this is the same thing as 1 plus of 0.2 for 20% to the power of 7. And if I type that on my calculator, I will get 3.583188. So there's a lot of numbers. But if you have a look, sorry about that. If you have a look at the numbers present, they are given to 4 decimal places. So there's actually a bit more at the end. Okay, so just remember that because I'm going to talk about that in a second later. Right. Now let's go to one of the questions to see how this works. So we can use an example of Mahmoud's term deposit. Mahmoud invests $7,000 into a term deposit account for 3 years where it earns 5% per annum. Use the table to find the future value of the investment. So remember, we've actually done this before without a table. So without a table, we can use our formula A is equal to P bracket 1 plus R to the power of N, which is our compound interest formula, which is now this formula. We know that the principal, in this case, or present value, is going to be 7,000. We know that N is 3 years and the rate is 5%. So putting this into our formula here will get us 7,000 times 1.05 cubed, which does result with this value and approximates to this to 2 decimal places. Now with the table, you've got to find out the interest factor just by looking at the number of years and the interest rate, and they both have to be exactly the same duration, which in this case is perfect because they're both in years, right? So let's have a look. 3 years and 5%. 3 years means a period of 3, and 5% meaning this. So if we look at the intersection of those two values, it is 1.1576. Okay? So we'll have FV equals PV times 1 plus R to the power of N. But this part of our formula is now the number that we've got in the table. So present value is 7,000, but the value that we got from the table was 1.1576. Now when we multiply these two numbers, we do get exactly 8,103.20 cents. Okay, so what do we actually notice with our two answers? They are just slightly different. And remember why? It's because this number was rounded. Okay? There was actually more numbers after this, but because the table has only 4 decimal places, it would be just slightly inaccurate, okay, but it's close enough. So this is exemplified by that example I wrote before, where this is now turned to this number, okay? So that's how you do it with that question. Let's have a look at another example. So this is the same future value interest factor table at $1. Now for example 8, Stephanie invests $2,000 into a term deposit for 5 months where it earns 12% per annum paid monthly. Use the table to find the future value of the investment. Okay, so if we're going to do it with the table, what happens is that we will look at this for 5 months. Okay, so with the table, right, we're going to get the future value equal to the present value, which was 2,000, and we're going to multiply it by some value in the table. But we first have to look at the fact that this is to do with months, and this is to do with years. So if we were to change this to months, it will be 1% per month, simply by dividing by 12. And now we have to look in the intersection of a period of 5 months at 1%. So 5 months at 1% would be this value here, which is 1.0510, and that's our interest factor. So it's 1.0510, and that will give us $2,102. Okay, whereas normally without the table, okay, this is what would happen. You would have, FV equals PV 1 plus R to the power of n. So PV is our present value, which is $2,000, and we'll times this by 1 plus 0.01, because it's 1% per month, and we'll raise that to the power of 5. So if I do that on the calculator, I will get $2,102.0201, and you can see that there's a slight discrepancy here, okay? But it doesn't matter too much. Right, let's now have a look at present value of investments. So we just looked at our future value, which is what happens later on when we put in an amount in the bank and let it grow. But the present value is all about how much you would have to invest now to end up with a certain amount in the future. So say, for example, you may be saving up for a holiday or a deposit for a house. So you really have to know how much you're going to put in the bank now and wait for a certain number of years to grow to the amount that you want. That's called the present value. So without the table, you know that FV, present value, is PV, present value, times the interest factor. We can divide this interest factor over and get present value is future value over 1 plus R to the power of n. And our future value in this case is the number 5,000, whereas the rate is 5% per annum at 4 years left at the bank, and that will get us this amount there. Now with the table, okay, we do exactly the same thing, right? We're going to do 5%, okay, for 4 years, right? Okay, so let's have a look at that. 5% for 4 years, okay, look at the intersection of those two values, and that'll be 1.2155. So what we're going to do is we'll substitute it into this, okay? So our future value is 5,000, and now that's equal to PV, which is our present value, and we're multiplying that by 1.2155. So now if I want to divide that number over, I will get the present value, which is 5,000 divided by 1.2155. Let me just see what that gets you. So 5,000 divided by 1.2155, that gets me 4 1,113.5335, and so forth. There's more numbers after that. Okay, so you can see that again, it's rounded to become just a slightly different number. Okay, but it helps reduce the workload here. Okay, so that's their answer.